Good morning, everybody. What I wanted to do today was to work through the practice test in preparation for your test later in the week. So what I'll do is I'll work through the answers and just explain each one of these problems. So if you could attempt the practice test first of all, and then slowly work through this PowerPoint, you'll be able to see how to work out these problems in preparation for your test. Okay, so the first one is a 120 scale of 30 centimetres. Now what that means is that the scale is 20 times smaller. So a model is 30 centimetres long, so we need to work out the size of the real life plane. So that's going to be equal to the original 30 centimetres, and we're going to multiply that by 20 because the real life model is 20 times larger, and that's equal to 600 centimetres. Now you could, if you wanted to, convert that to metres. So you can divide by 100, and that's also equal to 6 metres. A person 170 centimetres is represented by a model plane. In the model plane, how big would that person be? So the person, we have to do a reduction in size. So we take the original 170 centimetres and we divide that by 20 because the person has to be 20 times smaller. So that works out to be 8.5 centimetres in height will be the model which needs to go into the plane. So quite easy, we just look at the 1 to 20 ratio and we either multiply by 20 or we divide by 20. If we're going from the model to real life, then we multiply. If we're going from real life down to the model, then we divide by whatever the ratio is. Question number 2, we've got a triangle and we have to identify the scale factor. So we've got two sides, 4 centimetres on the scale and 10 centimetres on the real. So what we need to do is to work out the scale factor, and the scale factor will be equal to the real size, which is the 10, divided by the 4. So the 10 centimetres aligns with the 4 centimetres in the triangle. So that works out to be equal to 2.5, or you could write it down as 2.5 if you would like to. So the scale is 1 to 2.5. So 1.2.5. In other words, the real image is 2.5 times larger, or going back the opposite direction, we divide by 2.5 to make the smaller model. Use the scale values to work out x and y. So to work out the x value, x is equal to, now x aligns with the side which is 5 centimetres in length. So this x side aligns with the 5. So we're going from the scale to the real size. So we're going 5 and we're multiplying it by 2.5, and that works out to be equal to 7.5 centimetres. Going from the y, the 3 centimetres and the y align, so those are the two sides. In this case here, we're also going from the scale to the real, so we're going to multiply. So the y is equal to the scale, which is 3. We multiply it by 2.5, and that works out to be 7.5 centimetres. Oh, made an error there, sorry about that. Do a bit of multiplying, my multiplying's out. This is 12.5 centimetres. Okay, so that's our scale question to do with our triangle completed. Then we go on to a problem similar to you had in the assignment, which is the house. So the scale for this house is 1 to 110. So the real house is 110 times bigger than the scale. So use the scale to do the overall dimensions of the plan. So I'm going to measure the length of this. Approximately I got the actual length equal to 10.1. So I'm going to take the 10.1 and I'm going to multiply that by my factor of 110, and that's going to be equal to 1111. Right, now I could divide that by 100, which sort of makes sense, and that equals 11.11 metres. So my width is equal to my width. I measured that to be equal to approximately 11 centimetres. So I've got 11. I multiply that by 110, my scale factor, and that equals 1210. And then I'm going to divide that by 100, and I get 12.1 metres. So these are only approximate measurements. If you get something close to that, then that's perfectly okay. If the carpet costs $75 per square metre, how much carpet would cost the carpet for the bedroom 1 and bedroom 2? So what we need to do is to work out the area of bedroom 1. So we're going to go bedroom 1. Bedroom 1 is about 4 by 4.4. So multiply those together, we get 21. We're going to multiply by scale factor first of all. So multiply the 4, of course, by the 110, the 110. And the other dimension is approximately 4.4. We're going to multiply that by the 110. And that works out to be about 4.4 metres by about 4.84 metres. Alright, so we multiply those two together to give me the area. So the area of that is equal to 4.4 multiplied by 4.84, which is 21.296 metres squared. Now we do the same for bedroom 2. So bedroom 2 is approximately 4 metres as well by 110. That produces about 4.4, the same as above. And the other dimension is 3.7 multiplied by 110, divide by 100, and that works 4.07. So the area, I'll call this one bedroom 1, bedroom 2 is 3 points. Oops, take that out, I got the wrong number. 3.7, I've got the wrong number again. 4.4 multiplied by 4.07, and that's approximately 17.908 metres squared. So what I need to do is to work out my total area of my 2 bedrooms now. So I'm going to add those 2 areas together. So total area is equal to 21.296 plus 17.908, and that comes out to be 39.204. Now I take that number and I multiply that by the cost of the carpet per square metre. So this is metres squared. So my cost is going to be equal to my area, 39.204, multiplied by my 75, and that comes out to be $2,940.30. So I work out my 2 areas. First of all, I do my bedroom 1, then I do my bedroom 2. I work out the area of each one of those bedrooms. So I do my dimensions, then my areas, I do my total area, and then I work out my cost. So they're the steps that I work through to calculate the cost of carpeting the bedroom. Alright, so that's pretty well finished with our scale. Now we move on to Pythagoras. So the first question is Pythagoras, the others are going to be sine, cos or tan. So I write down my Pythagoras theorem, c squared equals a squared plus b squared. Right, so this is going to be my c side, this is my a, this is my b. So I substitute my values in. 11 squared is equal to a squared plus 8 squared. Okay, so I'm going to take the 8 squared away from both sides. So I've got a squared is equal to 121 minus 64, and therefore a squared is equal to the square root, oh, I'll take that out, a is equal to the square root of 121 minus 64. So I put that in my calculator and I end up with 7.55 centimetres. Alright, the next one is a sine, cos or tan, because in the corner I've got an angle. I've got 70 degrees. So I look at my triangle and I think, what sides do I have? I've got my opposite side and I've got my hypotenuse side. So opposite and hypotenuse is going to be a sine. So sine of theta is my opposite divided by my hypotenuse side. So we go sine of 70 degrees is equal to my b divided by 14. So I need to move the 14 from the bottom, so I'm going to multiply both sides by 14. So times by 14, times by 14. So b is equal to sine 70 degrees multiplied by 14. So in my calculator, I make sure my calculator is set for degrees, or D. I put sine of 70 in, multiply it by 14, and I end up with 13.16. Now that will be in metres, so I have to put a metres on the end, and that's completed my problem. For the next problem, I've got my angle in the corner. This time I've got my hypotenuse, which is opposite the right angle, and I've got my adjacent side. So I've got the adjacent and I've got the hypotenuse. So this one's going to be cos. Cos theta is equal to my adjacent side divided by my hypotenuse. So cos 70 degrees is equal to, now the adjacent side will be C, and my hypotenuse is 65. So here I multiply both sides by 65 because I need to remove the 65 on the bottom, and that leaves with C is equal to cos of 70 degrees multiplied by 65. Alright, so I pop that in my calculator and I end up with 22.23, and it's going to be centimetres. Alright, for D, where's my angle? There's my angle in the corner. What sides have I got? I've got my opposite side and I've got my adjacent side. So this is going to be a tan. So tan of theta is equal to my opposite side divided by my adjacent side. Alright, so tan of 62 degrees, my opposite's 3.5, I divide by D. Now, I've got to remove the D by multiplying both sides by D. So therefore, I've got D times tan 62 degrees is equal to 3.5. Now I have to divide both sides by tan of 62 degrees. So D is equal to 3.5 divided by tan 62 degrees. Put that in my calculator and I get 1.86 metres. So not too hard. There's a sine, there's a cos, there's a tan, and there's a Pythagoras. Alright, for the next one, it says use the ratio to find the unknown angle. So we've got to work out what our unknown angle is going to be. So we've got our unknown angle is going to be our E down the bottom here. So this is where we work backwards and we use the inverse of our sine or cos or tan function. So I've got my opposite side and I've got my hypotenuse side. So this one is going to be equal to sine theta opposite over hypotenuse. So I don't know what sine is, so I'm going to go sine of E is equal to, my opposite is 8.4, I'm going to divide it by 9.1. I put that in my calculator, I get sine of E is equal to 0.9231. Alright, this is where we use the inverse, so we go sine to the minus 1 of 0.9231 is equal to E. So on my calculator I put 0.9231 in, sine to the minus 1, and that gives me a number of degrees, and it works out to be E is 67 degrees and 23 minutes. Now you might get a decimal there. That's okay. If it's 63 point something, that answers perfectly okay as well. For the next one, we've got to find out what F is. So I've got my adjacent side and my hypotenuse. So adjacent and hypotenuse. So adjacent and hypotenuse is going to be cos. So cos of theta is equal to my adjacent divided by my hypotenuse side. So therefore cos of F, which is my angle, adjacent side 6.34, and I divide it by 10.25. Put that in my calculator. Cos of F is equal to my angle. I'll go straight to the answer. I won't go through those steps again. F is equal to inverse cos to the minus 1 of 6.34 divided by 10.25, and that's 51 degrees and 47 minutes. Once again, if you get a decimal, 51 point something degrees, that's okay. So that's the cos one, and the last one. Now we've done a sine, we've done a cos, and I reckon this one probably will be a tan. So let's have a look. Here's G. We've actually got to find the unknown angle and then the unknown side. So could do this a couple ways, but let's just find G first of all. So I've got my opposite side and I've got my adjacent side. So I'm going to use tan to find the big G value. So tan of big G is equal to my opposite 6.5 divided by 3.5. So G is 10 to the minus 1 of 6.5 divided by 3.5. I'll put that in my calculator. 61 degrees and 42 minutes. Alright, now I need to find the small g value. So the small g value, I can use a trig ratio or I could use Pythagoras. And I'm going to use Pythagoras because it's probably easier than looking up my trig ratios, but I could use a sine, cos or tan to find it. So, not a tan, sine or a cos. So let's just use Pythagoras. So c squared equals a squared plus b squared. Now the hypotenuse is the c side, which is where the g is. I'm going to call this one the b. I'm going to call this one the a. So c squared is equal to a squared. So my a squared is 3.5. My b is 6.5. So therefore c is equal to the square root of 3.5 squared plus 6.5 squared. So I work out the squareds, then take the square root of it, and I end up with 7.38 meters. Okay, so that's using Pythagoras, that's using our sine, that's using our cos, and that's using our tan to calculate our different values. Alright, let's march on to question 5. Question 5 has built in a 3.8 metre ladder. So let's start writing on information as we get it. So 3.8 metres, a ladder, against a wall with a foot 2.2 metres from the base of the wall. So it's 2.2 metres out from the base. And carefully label the diagram, which we're doing. Label the diagram below, determine the angle the ladder makes with the wall. So we've got to make with the wall, we've got to try and find our theta. So here's our wall, okay, here's the ground here, and what we want to do is, there's a 90-degree corner, we actually want to find out what the angle is. So I'm going to use one of our trig ratios. So I've got my opposite side and my hypotenuse. So I'm going to go with sine. Sine of theta is equal to opposite over hypotenuse. Then I'm going to put in sine of theta, my opposite 2.2, my hypotenuse 3.8, and therefore theta is equal to sine to the minus 1 of 2.2 divided by 3.8. Put that in my calculator. I end up with 35 degrees and 23 minutes, or 35 point something degrees as your answer. So that's pretty easy. It's just same as the questions above. It's just a diagram we have to work it out from. Alright, Andy is standing on the top of a lighthouse, 150 metres above the sea level. So let's write 150 metres here. So that's there. This must be the sea down here. And he's looking direct east. He notices the boat is an angle of depression, 39 degrees, and also a rock, which is 29 degrees. So an angle of depression, so if I put a dotted line here, I can put down my angle of depression. So one is to the boat and the other is to the rock. So the angle of depression to the boat is 39 degrees. So this is 39 degrees, which means that this is 39 degrees. And the angle of depression to the rock is 29 degrees. So this is 29 degrees. So this one here has to be 29 degrees. Okay, what do we need to find? To go further, label the diagram. Pretty well done that, which is good. So now what we do is determine how far the boat is from the rock. So what I'll do is I'll put C down here, the boat from the rock, and we'll call this one D. So that's how far the boat is from, oops, wrong one, D, the boat from the rock. Alright, so to do this problem, we need to do it in two steps. We need to first of all find out how far the boat is from the wall, or the rock wall. Then we need to find out how far the rock is from the rock wall, and then we need to take the two away. So let's call this one D1, D1, and this one is the big one. We'll call this one D2. So I'm going to label this one here as D2. There's that one there. So I've got two triangles that I'm working with. So let's first of all find out how far the boat is away from the bottom of the wall. So here's my triangle. Looks like this. Determine how far the boat is from. So the boat is from the rock. So let's work out first of all how far the boat is from the wall. So this is going to be D1. This is 39 degrees and it's 150 metres high. So my ratio I'm going to use will be my tan ratio. Why my tan ratio? Because I've got opposite and I've got adjacent. So tan 39 degrees is equal to 150 all divided by x. Now rearrange the problem like we've done before. So we multiply both sides by x, divide both sides by tan 39 degrees, and we get x is equal to 150 divided by tan 39 degrees. I put it into my calculator and I get 185.23 metres. Alright, now the other measurement we need to work out is the D2. So the D2, I'll put in here, D1, D1 and D1. The other one is going to be the D2 measurement. So what does that triangle look like? Well, it's very similar. 150 metres, 90-degree corner, and we've got 29 degrees, and this is going to be D2. So once again, which ratio do we use? I'm going to go with tan. I've got opposite, I've got adjacent. So tan 29 degrees is equal to 150 divided by D2. So once again, multiply both sides by D2, divide both sides by tan of 29 degrees, and we get D2 is equal to 150 divided by tan 29 degrees. Put it in my calculator, I'll end up with 270.61. Alright, now what I need to do now is to work out what D is. So D is equal to the big distance D2, subtract away D1, and that will leave me with my value of D, how far the boat is from the rock. So I'm going to write down D is equal to D2 minus D1, which is 270.6 minus 185.23, and that equals 85.38 meters. Okay, so I use two tan ratios. My angle of elevation is the same as my angle of depression. So the key here is 39 degrees is my angle of depression. That's also my angle of elevation. 29 degrees is my angle of depression. 29 degrees is my angle of elevation. So then once I've done that, I've got two triangles. I've used my tan for both of them, worked out the two distances and subtracted them away, and I've got my distance from the boat to the rock. So these are like two-step equations. So you can't do these in one. So you need to be careful and think, what do I have to do first, then second, and then find a final answer. Right, question 7. Make a hole in this paper. Use two methods, three-figure true and compass bearings to give the bearing of this. So 47 degrees. Well, 47 degrees, let's do the true first. That's just 047 degrees T, or you could have just 47 degrees T, either one of those two. The other would be north 47 degrees towards the east. So I go in a northerly direction and I go 47 degrees towards the east, okay, which is my angle. For the next one, I've got 90 degrees and 90 degrees, okay, and this is 60 degrees because it's 90 minus 30. So my true bearing in this case will be equal to 90 plus 90, which is 180, plus 60, which is 240. So my true bearing is 240 degrees T. And my 3.3 figure is a southerly direction, 60 degrees towards the west. So I go in a southerly direction, I go 60 degrees towards my westerly direction. So to help you, you could go east, south, west, east, south and west. That could help you with your working out your answers. So, two bearing ones, that's not too bad. Question 8. Question 8 says, Alistair runs 3.6 kilometres due north and then heads due east. So what I'm going to do is I'm going to make this one northerly direction. I'll make this one the easterly direction. So, person starts running, they go 3.6 towards the north, and then they run 4.1 towards the east, and they're running kilometres. And what we have to do is determine the distance is from the start. So I'm just going to call this one D. So here's where Alistair finishes up. Here's the start down here. So we've got to work out what our D is. Now, I'd use Pythagoras theorem for that because I've got three sides and no angles. So C squared equals A squared plus B squared. Let's see, so it's going to be D squared is equal to 3.6 squared plus 4.1 squared. Okay, so D is equal to the square root of 3.6 squared plus 4.2 squared. So it doesn't matter. I made this one here my A, this one my B, but they could be opposite way around if you'd like. Okay, I work that out and I put it in my calculator. I get 5.46 kilometres. So that's how far Alistair is from the start of where he began. Work out the bearing of Alistair is from the start. So the bearing from the start will be, here's the start. So we're going from the start to Alistair. So we have to work out what this angle here is. Okay, so I've got to find an angle, so I have to use sine, cos, or tan. I think I'll probably use tan. So I'm going to use the opposite side and the adjacent side. I could use either sine or cos if I wanted to. I'll go with tan. Tan of my angle, of my bearing, is equal to my opposite divided by my adjacent. Opposite side, 4.1 divided by 3.6. Put that in my calculator. Theta equals tan to the minus 1. So I do the inverse of 4.1 to find the angle. 3.6. And I put that into my calculator and I get 48 degrees, 43 minutes, or you might get a decimal. Now the bearing, that'll be a true bearing. So my bearing could be 48 degrees, 43 minutes T, or it could be a northerly direction, 48 degrees, 43 minutes towards the east. And there's my two bearings that I've got. So not too hard. I use my tan to work out my angle, and then I just simply turn that into a bearing, which is from the north around towards the east. Question 9, which is the last question. It says a ship leaves port and sails 8.3 kilometres and a bearing of 35 degrees. So if they're going north 35 degrees towards the east, there's my 35 degrees. The distance it goes is 8.3, and it's going to go 8.3 kilometres. And then it sails due east from A. So this is my northerly direction. This would be my easterly direction. So there's my 30 kilometres towards the east. And I'm asked to, first of all, using the knowledge of the triangles, determine the distance the ship bearing from the start. So what we're going to do first of all is to work out the bearing from the start will be from here around. So using the knowledge of two triangle problems, determine the distance and bearing the ship is from the start. So we'll put another line in here. I'll do it in red just to make it clearer. So what we're going to do is to find the D, and we've also got to find this angle, which is the bearing from the start. Now I can create a couple of triangles here. I can draw a line across here. So if I could find the length of this side against the north, then I could also determine the distance across the top, and that would then enable me to do my my bearing and also my distance. So I'm going to call this, let's say, D1 and D2. So I'm going to find D1 first of all. Let's draw that triangle. So draw it here. Here's my triangle. 35 degrees. I know that I've got my distance of 8.3, and I'm going to call this one D1. Oh, sorry. Yes, D1. So I need to work out what my D1 value is equal to. So what am I going to use? Well, I'm going to use the trig ratio. I've got adjacent and I've got hypotenuse. So I'm going to go tan of theta is equal to, sorry, not tan. I'm going to use my cos ratio because that's adjacent and hypotenuse. So cos of my angle, I know, I'll call it just angle A. That's equal to opposite divided by my hypotenuse. No, it's not opposite, it's adjacent. ADJ. Okay, so cos of 35 degrees is equal to my adjacent side D1 divided by 8.3. And I multiply both sides by 8.3. So D1 is equal to cos 35 degrees multiplied by 8.3. And that's equal to 6.8 kilometers. So let's write that on our original diagram. This is now 6.8 kilometers. Right, now if I can find D2, which is the distance across the top of my triangle, then I can calculate my total distance across the top, which would be 30 plus D2. So let's redraw that triangle. So the triangle looks like this. I'll use the 35 degrees again. So 35 degrees. I know this side's 8.3 and this one is going to be D2. There's my 90 degrees. Right, which ratio do I use? Well, let's see. There's my angle, opposite, hypotenuse. So, opposite and hypotenuse, I think I might go maybe with sine. So, sine of my angle, A is equal to D2, my opposite divided by hypotenuse, 8.3. So, D2 is equal to sine of 35 degrees multiplied by 8.3. So I multiply both sides by 8.3 and I end up with 4.76 kilometers. Alright, so now what I need to do is to work out my distance from starting point and my bearing. Okay, so let's have a go at that. So what's the triangle I'm actually got now look like? Well, it looks a bit like this. I know this is 8.3 kilometers. I know my distance on my side was 6.8 kilometers. So that's 6.8 kilometers. I know this one on the top is equal to 4.76 plus 30, which is 34.76 kilometers. So what I need to do is to find that big bearing. Okay, and oops, that's the other triangle, that distance. I need to find this distance on the side. And what do I call that one? Well, did we give it a name at the top here? We did. D. So I'm actually going to call this one D. So that's now the large triangle. And I've simply got to work out an angle. And I've got to work out a length. So how could I work out the length? Well, let's do D first. I'd use Pythagoras because I've got 3 sides and I can work out my unknown side. So first of all, working out my distance, c squared equals a squared plus b squared. So d squared is equal to 34.76 plus 6.8. Then I'd say therefore d is the square root of all that, 34.76 plus 6.8. I work it out in my calculator and I get 35.42 kilometers. So from the start to where the boat finished, which is I think point C, there the distance is 35.42. And my last thing is to work out my bearing. Now to do my bearing, I could use sine, cos or tan. I think I'll just use tan. Tan theta is equal to my opposite over my adjacent. Okay, so which one's my opposite side? Here's my opposite. Okay, here's my adjacent. I could use sine or cos, of course, but I might stick with tan. I've used that before. So therefore tan theta is opposite 34.76 all divided by 6.8. So my angle is tan to the minus 1, which is my inverse, 34.76 all divided by 6.8. And that gives me 78 degrees and 56 minutes. But once again, you might get 78 point something degrees. That's okay for an answer. That's perfectly right. Now that's not my final answer for my bearing. I need to turn that into a form I know. So I could write it down as 0, write it down as 78 degrees, 56 minutes T, or north, 78 degrees, 56 minutes towards the east. And that'd be my final answer. Okay, so there's a bit of work in that. If you could work through those questions, just practice them, and the test that you're doing later in the week will be very similar to these, slightly different questions, but using the same sort of ideas. So thank you very much, people, for listening.